Welcome to Season 9 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hello, everyone. My name is Joris Peels, and this is another episode of the Prosthetics and Orthotics podcast with Brent Wright. How you doing, Brent?
Hey, Joris. I'm doing well. Doing a little traveling to the booming metropolis of Cleveland, Ohio.
Okay. What brings you to Cleveland, Ohio?
So I'm actually hanging out with a little bit with John Naft. So doing that, and we're just talking a little bit of 3D printing, and then he's doing a lot of stuff with Myomo, which is the kind of the exoskeleton for people that have had a stroke or a loss of a function of a limb. And so it's been really interesting to learn about that, and I love coming and seeing other people's practices. Then we talk shop, and so it's been really great.
The same thing that makes RoboCop can also make people walk again. It's very interesting if this will actually happen and when it will happen and then to what extent.
Yeah, no, 100%. And it's super cool. He actually had a couple fittings yesterday, and to see what the people. So what's really neat is they really concentrate on outcomes or outcome measures. So what can you do without the brace on, and what can you do with it on? And it's a night and day difference. It's incredible. So well, I'd love to do an episode on that. We can definitely get somebody from Myomo in there for sure.
Cool, man. We should. Okay, so do we have a sponsor? I think we have a sponsor from this kind of like 3D printing design service kind of thing.
Yeah,
Advanced 3D.
Yeah, have you ever heard of them, yours? It's crazy.
I've not. I'm not familiar. I think with.
So Advanced 3D is a contract manufacturer, but we also try to meet you wherever you are on your journey, whether you're just learning to scan, you're wanting to 3D print, or you move to definitive sockets to do that. And then we also, if you have a product that you want to bring to market, we can also help you with that. And so we're in North Carolina. You get to work with myself, Tyler, and Paul, and then we met Katie on the couple episodes ago. She's amazing, and try to help you wherever you are on your digital journey.
That's super cool, man. And you guys, what do you guys print in actually? Because you've got HP obviously, but what kind of materials can I order parts from you guys? Yeah,
so we do the multi-jet fusion color 5, so the 580. We can do PA11, 12, TPU, and then we've recently brought on PK 5000 from Jabil.
Really? You can talk to people about this because I'm super excited about that. We should do a PK 1000, the PK 5000 thing, because that is really exciting that you managed to get that to work and you're going to be using this for prosthetics, because that's an incredibly strong material, right?
It really is an amazing material. And believe it or not, we're going to have the guy that invented it on our podcast very soon. So that should be very fun.
Super cool. All right, then we'll leave a lot more on that. Okay, so who do we have on the show today?
Well, I'm super excited to have Luc Boronat on today. He is the head of the digital division at the Eqwal group, and he's also the CEO of Qwadra. And so Luc and I have known each other for a while, and I'm really looking forward to just hearing his journey. Where he's found himself now as part of essentially the conglomerate of Eqwal. But his company that had been around for a while, Rodin, was acquired a couple years ago. And so it's been I just am really looking forward to that. And he's been doing some amazing stuff, not only in the prosthetic and orthotic space, but also in this idea of clinician personal responsibility, design, automation. And so there's just a lot to unpack in this episode.
Awesome, dude. So welcome, Luc, to the show.
Thank you. Thank you, Brent. Thank you, Joris, for inviting me to share my journey in the ONP.
So how did you get started with the ONP?
Well, are you sure that you want to go in this?
You're not even probably going to be the furthest back we're going to go lately. So we've been getting, getting back to the 40s and 50s. So don't worry. Yes, we do.
Okay,
the very beginning.
I started at the very beginning my journey in 1983.
A kid, just a child.
I was yes. I was just 15 years old, and my mother said me that ONP company just nearby us was looking for an apprentice. Then, at 15, it was two words that I don't know. ONP, no idea what is it, and apprentice. Then I say, yes, why not? And then I started my apprentice in a very small ONP company located in Bordeaux, in France. Was specialized in only orthotics. I don't learn at the beginning the prosthetist.
Okay, so and the one thing that's really interesting, because I know that France, to a certain extent, also Germany, they have these apprenticeship programs. In America, they don't really have this.
Yes.
And so do you think it's a really good thing because you started as an apprentice? Do you think it's something that France, for example, should totally continue doing because it really teaches people a craft and a very hands-on way of learning things?
At this time, it was quite only the only way to learn the ONP field. Now it's completely different. It's a different study, but at this time you need to work 7 years in a workshop only, starting to see patient under the responsibility of the other CPOs. And after 7 years, I was able to be certified by the Ministry of the Veterans, equivalent of your veterans in US, who was taking care mainly about the ONP device at this time. It was quite the only way. I think the first school was created in 1982. In the same time, to learn to be how to be a CPO in France in a different way than to the apprentice. Now it's different, and it's impossible to start at 15 years to learn this type of works.
And how, when you got started making orthotics, what did you do? Was it a lot of leather, wood, carbon fiber? What were the materials you worked with?
I entered in the workshop for the first time and I discovered a forge and a machining lathe. Because in this company at this time, we build everything from scratch, from aluminum, iron, leather, everything. We have a machining lathe, as I said, to also produce the screw. Everything that it's probably at the beginning shaped my sense of independence. I learned to use all this old machining and how to be independent and produce everything. Yes, something that has followed me throughout my career all along the way. Yes.
And what has changed if you look at the materials? What are like the big things that you think are really like, the when you started with the lathe and stuff like that, what has really gotten people, a lot further than they used to be?
As I said, in 1983, it was just the beginning of the arrival of the polyethylene, who was a game changer for the body jacket, for example. At this time, we produced a lot of body jacket in plexiglass, and the arrival of the polyethylene was a kind of revolution.
Okay. And then how long did it take for you then to get more into prosthetics and stuff like that? Was it a long time, or did you focus really on orthotics for a really long time? Or?
No, I mainly focus only on orthotics all along my career. As I said, then after 7 years of apprentice, I was certified. It was 1990, and I worked at this time mainly on idiopathic scoliosis patient and cerebral palsy scoliosis. Yes, mainly during 10 years.
Mm-hmm. Okay. And we know that some of these braces and things have been 3D printed. Did you end up using 3D printing back then as well, or soon for this application, or not really?
Well, my first experience with 3D printing was during the 2006 probably, where we tried to produce our first BK sockets in FDM.
Okay. And did you think, oh my God, this is the future, this is going to be everything? Or was it like, oh no, this is never going to work?
Probably both. If you have a good imagination, you can think that it can be a revolution one day. At this time, it's the materials that we use. It was probably ABS. I don't remember so well, but it was ABS. Then with a very long process to produce it. But yes, for sure that we at this time imagine that it will be a big game changer in the profession.
And how is it? Is it taking a lot longer than you expected? Did you expect everyone to have 3D printers already, or yeah? How do you think it's going on site?
For us, I don't want to minimize the 3D printing, but I want to say it's only a tool. And today there is no one answer to all the one printer, one answer to all the needs of the CPOs. As they have a workshop with many machineries, probably in a few years they will have different 3D printers, to produce different aspects to the temporary sockets, to the definitive sockets with carbon fiber inside, or for body jacket with polypropylene, or also with the HP technology, with the TPU, with a very, very good material for the ONP. It's the answer today is diversity, on my point of view.
Okay, I like that approach. Just seeing it as a machine. It's not a revolution. It's just it's another tool we use. It's like a mouse or a lathe or whatever. I think that's a very kind of hype-free way of looking at the technology. And how about for insoles specifically and stuff like that? We've seen a lot of uptake in insole production with primarily like TPU or polypropylene, with like kind of desktop printers or kind of relative inexpensive. Do you think that's going to get much bigger?
Yeah. Definitely, yes. We have 3D printers who print foaming TPU, and the market is probably a little bit different here in Europe than in US, where we produce a lot of soft insoles. I mean, with CAD/CAM by carving like a TP foam or something like this, and now with 3D printing with TPU with FDM. That it's already something that we have on markets since some years.
So I want to hear a little bit about. So I find it interesting. I didn't realize how involved you were on the scoliosis side of things, and I want to hear about how that also helped you to create the Rodin. Back in 2003. Like, what was the journey to be like, hey, I need a digital tool so I don't have to mess with these massive plaster models?
Yeah. I need to come back in 1980 when I was 12 and I bought my first personal computer. At this time, it was a ZX80. I don't know if you know that. It's from a company, Sinclair, an English company. And at this time, you receive the computer, you have to weld all the components before to plug it on the family TV and start to programming. That is my first experience and my first journey in I want to say IT. And all along my career, I developed some softwares, mainly for managing the production in the workshops. And one day I was very interested by 3D, and then I continued developing and some softwares. And in 1997, in the group where I'm working in France, we decided to invest in the Swedish system at this time named CAD. It was bought by Osu after, and it was a CAD/CAM software working only by scanning. And yes, we started our experiences with this type of tools, and we reached rapidly the limit of the tools because we wanted at this time to invest in a system, always to scale up the use of the CAD/CAM, but also to scale up the central fabrication. At this time, we was taking a plaster cast, as you know, and sending plaster cast, and there is no sense for that. And we wanted to really have a tool, not only to show that we are using CAD/CAM, but really a tool to scale up the company at another level. Then I developed a first software for only designing body jackets and scoliosis body jackets. And at the same time, we developed our first carver. It's with a partner nearby us in the area. And that's the first experience that we had that I had and that we had in the company with the CAD/CAM. In the same time, we need to also develop a complete workshop of how to produce polyurethane blocks to carve in the carver. Then we develop all the tools. I developed all the tools, the polyurethane blocks, the software, and the carver. At this time, for sure, the 3D scan was very expensive. And then it's why we was concentrate at the beginning on the body jacket, and we developed some 3D libraries working by measurement only, that we don't need to take a full 3D scan. And progressively, when the price of the scan decreased during it started in 2008, 2010, then we can scale up more about device. We need more accuracy, like A4s, AK, BK, but yes, mainly that.
And I'm interested that you guys have always kind of like, you notice well that, okay, you make the whole solution, right?
Yeah.
Was that because you had to do it, or because you wanted to control it, or you think that was a good product for people to just have the material, the software, the machine, everything together?
Yeah, as I said, the way to be independent and to probably because our DNA and my DNA is from the ONP field, I never feel comfortable with standard tool from the industry, and then we decide to develop it for our internal use. And as we were a company a little bit well-known, ONP company a little bit well-known in France, that we have many visitors at this time, and each time they saw our tools to produce, they wanted to buy, and it's why we decided to put it on the market and to sell the full solution.
And was it but was it difficult for you to get into, so you're trained to do all this podiatry stuff and all this, and all of a sudden it's software, it's machine, it's G-code. How did you do that? Did you just learn everything yourself, or did you, how did you kind of do that?
At the beginning, I want to say yes, but now we hopefully I still don't develop, and we have a lot of engineers and very clever people who are handle that better than me at this time. But yes, it was a way to learn all these type of things, to connect all these tools to make a full solutions for the ONP market. Yes.
So one thing that I find fascinating, Luc, about this journey, what it sounds like is you created the tools essentially for yourself because you needed it. And then you have these guests that come in and they look around and they say, where can I buy that? And you're like, where? I think I need to start a business and to be able to sell it. So I think that's fascinating to me, because I think that there's so many people that look at the ONP market and they're like, hey, we can build tools for them, but they don't actually have an understanding of the pain that we go through as clinicians, or even the evolution of how we've gotten to where we are. And I think that's kind of your secret sauce, I guess, if you would say, is like you have all this experience from not only making your own aluminum and iron stuff now to programming and all that, but you have this kind of vast experience of being very focused on solutions from real problems that you have.
That's true. That's what's drive me at the beginning, but still driving the company. We are lucky that to have this digital division now, who is connected to this big group of Eqwal with more than 250 clinics worldwide, and we are still connected to the patients. And all the engineers who are working now with us have the ability to see the patient, to understand the needs of the clinicians, and that's still driving the opportunity to support the CPOs worldwide.
Yeah, and well, before we get into that side of things, I just wonder, like, how do you decide as a person doing, especially on the software side, what solutions you need or what problems you need a solution to, right? So how do you filter that? So definitely at Roden, when you had your client base essentially, or your customer base, and now with a bigger customer base, with maybe some people that are experienced, some people that aren't experienced, how do you filter those things of, hey, these are features that we want? Which one? How do you choose?
A good question. Thank you. Probably at the beginning it was more easier because the choice of the diversity of the. Sorry, I want to mean now there is more diversity of technology, and the choice is more difficult to choose the good direction. At this time, the problem was clear, and there is no so many solutions. And but as you said, rapidly we build a community of users internally, but also we build progressively. We had many customers worldwide, and when we gather them, we work on that, and we analyze the needs, and then the best idea win each time. And we was very reactive and develop fast the new tools to give access to answer the needs of our customers. Yes.
Let's talk a little bit about carvers, because you guys make a number of carvers, right? So you, what's the latest and greatest in the world of carvers? Are these getting cheaper, more convenient, faster? What's happening in this carver development?
Yeah, we started with a 3D axis carver. And it's not really 3D. It was not really 3D axis carver. It was 2.5 axis, because we obtained the 3D by the rotation of the mold. Then it allowed us to make all the positive shapes that we need. It was a little bit different when we wanted to carve. As you know, in Europe, we are making a lot of seats, custom-made seats, and with negative shapes that we need really to have 5 axes of freedom to do that. And it's why we developed a branch who integrated robot solutions. But for the daily things, AK, BK, body jackets, helmets, and so on, who made by carving, 2.5 carver was enough at this time. Again, in 1997, it doesn't exist really, and we needed to develop everything. And it's still we have more than something like 160 machines worldwide working, and still working on that. Of course, with the arrival of the 7-axis robot, it was also a game changer in term of time to carve now a body jacket in 12 minutes. It was not possible at this time with the carver, but it's possible now with the robots.
And these kind of robot-driven machines, right? Is it going to be much more expensive to buy one of those, or is it just a no-brainer because of the speed? Is it just going to maybe the investment's a little bit more, but then the speed is just going to win it back for everyone really quickly?
Still, we have it's why we still have an offer with the carvers, but in terms of productivity. Yes, it's more expensive, but in terms of productivity, it's more interesting to have this type of robot. Of course, you need to reach a certain level of production to be able to make the amortization of this type of investment.
Okay. And what are you seeing? Of course, you guys have got more a global perspective here. In the podcast, we end up talking a lot more about the U.S. often.
Yes.
Are you seeing a shift towards kind of more central fabrication, CFAB type of stuff? Are you seeing mom and pop shops do a lot more fabrication in-house? What are some of the trends you're spotting on the machinery side of things, let's say?
What we always wish is to give the tools for the CPOs can be as much as they can be independent. I mean, control their own orthopedic correction, control their own way to produce. But in the same time, we see that concentration on market and concentration on market may created big CFAB, and the need of big tools of production like robots.
Okay, and then and do you think this kind of centralization is going to continue across the world? Do you think there's going to be more bigger companies, or do you hope that these smaller shops are going to be really empowered by all these machines, and they could maybe in the future automate more and do more with automation, and maybe have to spend more time with patients?
It's what I wish, that the to keep this diversity on the market, because diversity make the offer for the patient at the end a variety of treatment, and it's what is important for us for the patient have access to a variety of treatments. But as we see today, there is a big concentration on the market. Yes.
Mm-hmm. And how about software? I mean, you used to have like a complete kind of CAD/CAM package. Now you've got more kind of automated workflows. Where do you see this going? Do you see people wanting like really powerful CAD tools, or do you think that people just want to press a button and then out pops the device?
I see both needs. Still, big central fabrication need. Horizontal offer, that's softwares who are able to correct a FO, but also an insole, but also body jackets. But in the same time, we see also some very specialized clinics, very vertical, who make only helmets, who make only 3D printing body jackets. Then the answer is not always the same, and it's why we have kind of different offers for different approach depending on the needs of the clinic.
Okay, and then I understand that you're. I like one thing I really saw was really interesting is that you make a mobile unit as well, a carver as well. And do you see most of the orthotics and prosthetics market seems to be very focused on the rich, kind of the OECD country people, right? The billion richest people on the planet. And we know there's like a much bigger market out there in also developing countries and also really poor countries, and they have different needs. Do you think that that's like, are you guys making tools for those people as well? Do you think that is going to be, because it seems like that could be where all the growth is, right? If these guys get richer, they'll be able to afford more sophisticated devices and they'll power a whole new wave. Is that something on your radar as well?
Yeah. We are working with a lot of NGO worldwide, and then when we analyze the needs, there are a lot of mainly different than what are the CPOs in the, I want to say, rich countries. Then the approach is a little bit different, and we want to have an answer to that also, and we want to keep that on our radar, because we have to serve all the patients. All the patients worldwide.
Mm-hmm, totally. And yeah, tell us a little bit about, because you guys made your own printer, right? The Arcad, which is like an insole printer, right? Yeah. That was, yes. And having come from that business, I bet that was a lot of fun, right? Compared to carvers and stuff like that, where it's all a bit more definitive and stuff. What was that whole process of developing a printer like?
Yeah, we wanted to digitize the podiatrist, and then we search a way to have a printer who is able to produce continuously. It means that all along the day, the podiatrist can design with the patients the insoles and send directly to the printer, and the printer 24 hours by 7 can print, and you know that the Arcad printer is printing on the belt, automatic belt. Then you don't have to make intervention between two printing, and then it's allow the printer to print 24 hours. and we are using TPU, foaming TPU, and we are able to print 17 different density with only one printer. That it allows us to simulate quite of all the materials that the podiatrists are using for the insoles. And yes, it was challenging, and we developed this printer during the COVID.
Okay, it was a COVID project there. I learned to bake.
Exactly.
No, and so how do you do this stuff? Because 24/7 operation, that's nice. You're going to put in a bunch of more expensive parts and make some longer lasting things. How do you do it, for example, with nozzles, right? Because start, stop, clogging nozzles is a nightmare. How did you manage to kind of circumvent that?
I think it's a little bit too technical for me. If I how we manage the nozzle, yes, it was critical at the beginning to find the way to clean up the nozzle, and we find the solution with a specific metal that we use, where the foaming TPU is not.
And also, like, I love that you're using foaming TPU. I think it's difficult to understate just how enthusiastic both Brent and myself are about foaming TPU generally, and what you can do with it, and how just how lightweight it is. And how many different kind of densities and properties you can simulate with this material. We think it's really amazing. I know that my favorite material in the world is probably PCL, actually, polycaprolactone, and then maybe I think Brent is right now moving towards more PEEK. But I think one of our favorite is this foaming TPU, just because it's so versatile. And how do you actually kind of dial in these kind of different hardnesses, softnesses, and you kind of use that material to the fullest? Because it's one of these things where people probably don't think that much of the fact that you can have a material, change the extrusion temperature and the extrusion speed, and then you get different properties, right? You can make something harder, and literally you could make something harder and softer in the same print and even in the same layer or area even. So how do you kind of design for that, or how do you explain that to customers?
Yeah, it was the main challenge. The plan was to try to digitize the podiatrist, and then, of course, the podiatrist is concentrated on his patient, and we didn't wanted to teach them how to use a slicer, how to use this and this, and it's why we integrate completely the scanner, the software, and the printer. That to obtain the 17 different density, we play between the foaming, as you say, by the temp, by the speed, but also about the infill of the 3D printing. And as we are printing on the belt with an angle of 30 degrees, that we always print the contour, that it's a very clean product at the end. That's an important way, because there is not so much post-processing, just to cut what you need, and that's all. That was the challenge, to really simplify the way, and it's each time our challenge, to translate the industrial tools to simple tools for our customers, and for the ONP and the podiatrist.
Yeah. And how would you look at this? I mean, from a positioning standpoint, it's very interesting because we have people that are trying to do this with Creality printers, like literally that, right? So the printer is super cheap. It's essentially like disposable. But there's a lot of manual labor involved with getting it out on the build platform. There's a lot of tweaking as well. Then now we have the option of doing it with the Bamboo Labs, which is what I'm trying to do at my house, which is, of course, more expensive, but better. And then you've got, like, you could, I guess, also do a lattice-based insole kind of on an MGF printer. And you guys are kind of in the printing in the middle of it. Do you think that the less handling and the focus on this TPU material, that's going to make this the best solution? Or is this, for a particular type of practice, you really are the best solution? What's the positioning of this thing?
I don't think that it's the solution for everything. But again, it was as you know, that we are based in Europe, it was more analyzed for the European market for these needs, even if we have now solutions in Canada also, but that the podiatrists in France are using in Europe soft materials, and this is the answer of the small podiatrist company who produce something like begin of 5, 10, 15 pair of insoles a week. And even if we have central fab who have 11 machines and produce more than 2,000 a month.
Oh, wow.
Yeah.
And it just comes, right, it goes off the belt and it comes down into some receiving bin or something, or?
Yeah, it's for,
okay.
At the end of the day, it's for.
Okay, and how big are the spools of material you can put in there? Because that's also another issue, of course, right?
We have you have 2 big spools of 4 kilo that it's allowed to print 100 pair. 50 for a spool, and there is automatic changing in the pool on the printer. Then when you launch the printer, you can print something like 80 or 100, depending on the size, of course.
That's cool. Oh, that's not bad. And how long does it take? There's like a couple of hours. Then you manage to do yeah.
It's an average of 1 hour 20 minutes by insoles.
Okay.
Almost 3 hours a pair.
Okay, not bad. Nice. And so talk to me about the soft and hard insole thing, because I just think it's really weird that like half the world is like soft insoles is the way to go, and the other half is like no, we need some carbon fiber hard stuff. Why is this a historical thing that just happened, or is one better? Or
no, probably yes. Mainly in France, the schools are teaching only this. Quite only this type of technology for correction of the foot with soft materials.
Okay, so it's a regional preference. Okay. I still think it's really weird.
Germany a little bit different, north of Europe a little bit different, UK also. It's more a mix of hard and soft.
I'm kind of curious too, Luc, just on your experience and your vast amount of travel worldwide. Is I know our listeners are always interested in how these regional differences. So we talked about hard and soft, but let's say like even AFOs, in Europe versus an AFO in the United States or Canada. What are some things that surprise you about some of the differences there? And it can be related to, our crazy system of L codes and billing, or something else. What are some of these differences that you see that are regional?
Yeah, it's often also why we need to provide different solutions because of the reimbursement price, and don't need to travel so much if you stay in Europe between some countries. An AFO can be reimbursed or code 300, 600, 1,000. It depends on the country. Then we have to adapt the technology of how to produce according, of course, of the reimbursement price. Technically, we are make for an AFO and to correct foot. We are quite all making the same, roughly the same things. In terms of details, of designs, and of functionality. Of course, there is diversity, but we don't see so much difference on that. The main challenge is to adapt the solutions to the price.
Gotcha. So you would say that like the philosophies of bracing are very similar, but it really comes down to how those philosophies are impacted via the fabrication method.
Yeah, driving by the what we call reimbursement prices.
And then just if we're looking at digitization, so just scanning, 3D printing, all that kind of stuff, is there a country or a region in the world that's much more mature, that's adopting the 3D printing of these other technologies much faster, or is everybody kind of going at the same rate?
There is, depending on the size of the company, and as maybe the concentration of the market started a little bit more earlier in Europe. Then we have biggest companies than probably in US. There is more pops still, as you say, pops and moms companies. Then the level of investment is a little bit different. The capacity of investment in CAD/CAM and the feedback on the investment also. Then we started to digitize China, for example, 10 years ago, and there is a big gap. On the rest of the world, I don't see so much difference. Probably in Europe, a little bit more. The technology is more adopted. Yes, earlier adopted.
Okay, and talk to us a little bit about Eqwal. Like, so first off, because we know it's one of the biggest groups in 3D printing, but Eqwal itself is, well, maybe not really well known to a lot of Americans, perhaps, or maybe I don't know. But talk to us a little about what is Eqwal exactly.
Eqwal, it's as I said you that I work always in the ONP company, and I enter in 1994 in a already a group of 70 people was named La Garrigue. And it's a typical French name, and we began to be a big group in France, and then we scale up with some investors, and then we needed to have a name who cover all our activity worldwide, and then it's why 2 years ago we create the Eqwal group, and then. That's the origin of the group. It's a ONP company, big group of ONP company in France, and now Switzerland, Belgium, Spain, and US and UK, of course. Where there is three main activity. You have the DNA of the group is the clinics. You have the component division, and you have the digital division.
And do you think that, well, if we're looking at that, I mean, we could understand that like doing all these different things at the same time could really have these economies of scale happening and stuff. Do you think, is that the secret to having to being a part of a group like this, that there's more money available to make more tools or something like that?
Yeah, together all these activities is give the power to serve the better the patients, of course.
So it sounds like I didn't even think about it in the three separate ways, but being able to really control in a good way all three of those, your components, your manufacturing, and then obviously the clinical side is a great way for the vertical integration to grow everybody together. And Eqwal seems to have a quite diverse portfolio to where you have guardrails, right, of what's available within even the digital tools, but then you also are able to play in a very large sandbox on a 8-lane road essentially. So I think that's pretty neat.
Yeah, you use a good word, variety, diversity, and it's we need to serve, and we have to serve. I mean, not only Eqwal, all the ONP company, a diversity of patients, and we need to have access to a diversity of tools. And then, but in the same time, to give the freedom of the CPO front of his patient to choose what is the best for his patient at this moment, and not only because it's accessible in a group.
No, it's a wonderful sentiment, Luc. So, Luc, thank you so much for being on our podcast today.
Thank you.
And Brent, thank you for being here again today.
This was so cool. Luc, thank you for sharing your experience and a little bit more of your journey. Just the vastness of the experience, hearing about your journeys, making your own computer when you're 12, and then making your own essentially raw materials to make the braces and such. I love that, and I just look forward to continuing to see what is next for you guys for sure.
Thank you very much to welcome me, and thank you for your contribution to the ONP community on what you have made. It's a significant impact.
So thank you so much, everyone, for listening as well. This is another episode of the Prosthetics and Orthotics podcast, and you have a wonderful day.
Hey, and that's all we have for you today. Thanks for listening to the Prosthetics and Orthotics podcast. And thank you to Luc from Qwadra for sharing his insights and experience. If you enjoyed this podcast, please give it a like, follow, subscribe, and tell all your friends. And until next time, have a great week.